Okay, so we're going to solve exponential equations. Just a quick rule to talk about. We have the property of equality for exponential functions, which means if you have a to the x equal to a to the y, then your two exponents are equivalent. The important thing is that both bases have to be the same. So if both bases are the same, then your powers are the same as well. We're going to use this rule in order to solve equations that look like this. So we have an exponential equation 2 to the x equals 16. Our goal is to rewrite it to look something like this. So we need to have like bases in order to solve this. Well, we can rewrite 16 as a power of 2. So if you think 2 to the 4th is 16, we can rewrite this equation as 2 to the x equals 2 to the 4th. That way we can immediately get to x equals 4 based off of the above property. Okay, similar, we have 9 to the c plus 2 equals 27 squared. Now, we can't rewrite 27 in terms of 9, but we can rewrite both of these in terms of 3. So if you think about 9, 9 is 3 squared, 27 is 3 cubed. So I rewrite the original problem like this. Then there's a exponent rule that says a power raised to another power says we multiply these two exponents. So the left side becomes 3 to the 2c plus 4. The right side becomes 3 to the 6th. Since these are the same bases, we can set our two exponents equal to one another and solve that linear equation to get c equals 1. We can even do this with fractions. So we talked earlier that 16 is 2 to the 4th power. This time, though, 16 is in the denominator. And if you recall from the beginning of the year, to get an exponent to the denominator, we negate it. So we can rewrite our original problem to say 2 to the x equals 2 to the negative 4. Again, that negative takes care of the fraction. And then we can say that x equals negative 4. Okay, we won't always be able to write both sides with the same basis, so we are going to recall our power property for logarithms. So remember, we can bring that exponent out in front of our logarithm. Knowing that, we want to solve this equation. So 200 equals 1.05 to the x. We're obviously solving for x. In order to get that x out of the exponent, we have to take the log of both sides, because the only rule that we know thus far to get a variable out of the exponent is that power logarithm rule that we just talked about. So if you take the logarithm on the right side, you have to do it on the left side as well. So log of 200 equals log of 1.05 to the x. Now we can apply that rule and rewrite the right side as x times log of 1.05. Okay, solving for x, we just need to divide by log of 1.05. This is a number. Okay, so that's a constant. Log of 200 is a constant, something you type into your calculator. So x is equivalent to log of 200 divided by log of 1.05, which gives you roughly 108.59. Okay, this one's a little more complicated. So we have 4 to the negative y equals 7 to the 2y plus 1. Since both of our sides of our equation have a variable in the exponent, we can take the logarithm of both sides. So I applied the power log rule. So we have negative y log of 4 equals 2y plus 1 log of 7. That exponent has to go in parentheses because the logarithm of 7 is applied to the entire exponent. Now we're going to kind of follow some algebraic rules. We're just going to distribute that log 7 through. So the left side stays the same. Then we have 2y log of 7 plus log of 7. This log of 7 is just a constant, so it's going to stay on the right side. We need to get our y's together, though, so we're going to subtract this 2y log of 7 to the other side. So now, after we subtract, we have this equation. Our goal is to solve for y. We cannot combine these two logarithms because they are different logarithms. This is log 4, log 7, but we can factor out a y. So when we factor out a y, we're left with negative log of 4 minus 2 log of 7, still equal to log of 7. And now everything inside this parenthesis is just a constant, so we're going to divide both sides by that. This is a calculator problem. Be careful with your parentheses when you enter it in. You should get negative 0.37. And last, I would like you guys to solve this one. Since our exponent is on a base e, you can use natural logs. All the same rules apply for natural logs, so try using natural logs to solve this.